So we're going to do the same example, but this time I'm going to use two different points, or two different sides of the triangle, because I feel like using AC and that being a vertical line isn't the norm, so I want to show you what it looks like when we end up with two equations with a y equals. So I'm going to do the same work that I did with segment AB, right? So remember that circumcenter, we think about the intersection of the perpendicular bisectors. Okay, so perpendicular comes from using slope, bisector comes from using midpoints. So I have to really focus on slope and midpoints, all right? So I'm going to look at AB first. And we're going to look at the slope of AB, okay? So remember slope, y2 minus y1 over x2 minus x1. So this is going to equal -1 minus 3 over 6 minus 0, so that's -4 over 6, that's -2/3. So the perpendicular slope, which would be the slope of the perpendicular bisector, is going to equal +3/2. Okay? Then we need to find its midpoint. So the midpoint, x1 plus x2 over 2, y1 plus y2 over 2. So substituting everything in, we're going to get 6 plus 0 over 2, comma 3 plus -1 over 2. And that's going to equal 3, comma 1. So our midpoint is right there, and it has a slope of 3, 2. So we're really focusing, like I said, on those bisector, the lines, right? So if I were to think about drawing in that perpendicular bisector, looks like that. We need to find the circumcenter, which is an intersection of lines, and that comes from having two linear equations, a system. So I need to come up with an equation of this perpendicular bisector. So we're going to look at slope-intercept form, y equals mx plus b, where m comes from our slope and x and y come from the midpoint. So we get 1 equals 3/2 times 3 over 1 plus b. So 1 equals 9/2 plus b. So b is going to equal -7/2. So the equation of this perpendicular bisector is y equals +3/2 x minus 7/2. And we actually did this exact equation, all the work and everything, for the last example when I did take 1, we could call it, right? But now I'm going to be looking at CB. In the first example, I looked at AC, but now I'm going to look at BC, so you can see how it's a little bit different. So I'm going to use a green pen for this one. So if I look at segment BC, okay, we need to find the slope first. So the slope of BC, y2 minus y1, so 3 minus -1, which is plus positive, and then 10 minus 6. So we get 4 over 4, which equals 1. So the perpendicular slope, which is the slope of the perpendicular line, is going to be -1. That's the opposite reciprocal of +1. Now we need to do the midpoint of BC. So the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So that's 16 over 2, which is 8. 2 over 2, which is 1. So the midpoint is at 8, 1. And again, we need to find the equation of this line, okay? So here's my m that I'm going to be using, and here's my x and y I'm going to be using. So 1 equals, and this is in y equals mx plus b, right? So 1 equals -1 times 8 plus b. So 1 equals -8 plus b, so b equals 9. So the equation of this perpendicular bisector is y equals -x plus 9. Now, to find the intersection of these two lines, they both equal y, right? So I'm actually going to set them equal to each other. Now this is a little different than the other example, which is why I want to do this one with you. In the other one, we already knew x because it was a vertical line, so we were able just to sub in the value of x. Here you have to do some work. You actually have to set these two equations equal to each other. So bringing them together, we're going to say -x plus 9 equals 3/2 x minus 7/2. Now to solve this equation, I'm going to first eliminate the fraction by multiplying everything by 2. So I get negative 2x plus 18 equals 3x minus 7. So solving this, I get 5x equals, bring that over, what is that, 25? So x equals 5. Okay? Once we know x is 5, we can substitute it into one of our equations, and I feel like it's easier to substitute it into this equation here, right? So y equals negative 5, oops, I wrote it next, negative 5 plus 9, which is 4. So that means our circumcenter is at 5, 4, and what you'll know, if you remember, if you watched the first video, that's the same ordered pair as the last example, and it should be, because the circumcenter is going to be the place where all 3 of those perpendicular bisectors intersect. So they should all come up with the same circumcenter. So if your partner did, one way using 2 different sides to a triangle, and you did the other 2 different sides, that's okay. You should end up with the same answer.